In this movie, we're going to look at the fundamental distinction between direct illumination and indirect illumination. It's not simply a case of one versus the other. Typically, we want both, but it's important to understand the difference each makes to the visual appeal of the scene. In this scene right now, in terms of this light box, we have a point light positioned at the center of the scene, casting illumination in all directions. We also have this cube and a sphere. Now, both of these objects are casting shadows on the environment, but if you take a look at the way this illumination works, there is something definitely wrong here. Let's maximize the view of the scene viewport. Firstly, you can see that this cube is capturing light that is being cast from the point light, and yet faces turned away from the point light are appearing completely black. The same thing is happening here for the sphere. The faces turned away from the light are again completely black. This is not the way light works in the real world, because in the real world, illumination will come away from this point light, strike surfaces in the scene, for example, this green wall, and then bounce off. When they bounce off, they inherit some of the light from the wall and bounce off into the scene to illuminate more things at a slightly lower intensity. According to the principle of energy conservation, the bounce light can never give off more light than the original direct illumination. But still, the indirect illumination can be intense enough so that the surfaces facing away from the light should not appear completely black. To fix this problem in this instance, I'm going to select the cube and select the sphere and enable the static checkbox. In enabling the static checkbox, I'm telling Unity that the objects will never move during gameplay. Objects that don't move can have both their direct and indirect illumination calculated automatically by Unity very efficiently. In enabling both the cube and the sphere to be static objects, they now receive indirect illumination. Let's take a look at the features of that. I'm going to expand the Scene tab further to see this in more detail. Not only do the sides of the cube now not appear completely black, and not only does this look substantially better, but you'll notice that this face of the cube, for example, is tinted green, and that is because the reflected light from this wall is bouncing onto this surface and making that green. On the other hand, if I switch to the other side of the cube and take a look at this face here, as it's facing the blue wall, the illumination that has bounced from the blue wall and hit this surface is inheriting some of that blue. This phenomenon is known as color splash. In addition to this, we have a similar thing going on here with the sphere. We're getting this yellow tint on this side here. Now, there is a pretty harsh line at this point here, and this is to do with the light mapping for this object. In some instances, we can simply fix it by selecting the object, and in the Mesh Renderer component, we can choose Stitch Seams for the light map UVs. In this instance, it hasn't fixed the issue for this problem, but very often it does. I'm going to zoom out of the scene here and take a look at the scene further back to look at it as a single composition. We can see that as a result of the indirect illumination, this scene is looking much better. Not only that, but if I select the point light here inside the hierarchy panel and I move to the light component, we can see here from the settings that not only do we have an intensity setting for the light, but we also have an indirect multiplier that can artificially allow us to increase the brightness of the indirect illumination. By increasing this, I begin to increase the brightness of the indirect illumination. I can also reduce its impact if I feel that it's too intense, but I'm just going to leave this at a setting of 1 to keep it as it is. Now, of course, these settings can also be changed at runtime. That is what the real-time setting here means in the mode, that we can update these settings at runtime, and those changes will almost immediately be impacted inside the scene. So this is a rundown on the distinction between direct and indirect illumination. By featuring both inside the scene, you can greatly enhance the believability and the realism of your scenes.